Today we're going to talk about a new theorem and do a lot of application problems that involve factoring. So the first thing I want to talk about is what's called the factor theorem. And according to your textbook, it says x minus k is a factor of f of x only if f of k equals 0. Now, that seems very confusing because it's kind of written in an abstract way, so I'd like to show you what they're talking about with an example. So we have a parabola whose function is x squared plus 3x plus 2. So that's the graph of that graph or that polynomial. If you were to factor this, it would factor into x plus 2 times x plus 1. If I asked you to set this equal to 0 and solve for x, that's how you find the x-intercepts. You would get -2 and -1. And that's what this theorem is saying. They're saying if you can factor it into x plus 2, that means -2 is a 0. And if you factor into x plus 1, then -1 is a 0. So whatever is in the parentheses, when you set the parentheses equal to 0 and solve for x, that number is an x-intercept. That's what that theorem is saying. So why is that helpful? I have 3 examples of where we can apply that knowledge. It says determine if x minus 2 is a factor of this cubic polynomial. Well, if this is a factor, that means when I put 2 into the problem, I need to get 0 as an answer. So we're going to replace all of our x's with 2's and simplify, and we're going to end up getting -10. So -10 isn't 0. If you don't get 0, the x minus 2 is not a factor. So if you want the answer to be yes, you need to get 0 as an answer. So if we want to test if x plus 3 is a factor, we just simply need to plug in -3 for x. So here's the setup. And if you were to go ahead and compute all of that out, you will actually get 0. So yes, x plus 3 is a factor because -3 is a 0. So if I give you 2x minus 1 and ask if that's a factor, well, if you would set 2x minus 1 equal to 0, you would get 1/2. So we need to see if 1/2 is a 0. So we just simply substitute 1/2 in for x, and we actually will get 0. So yes, 2x minus 1 is a factor. And that's basically how the factor theorem works. So you're really just looking to see if you get an answer of 0 whenever you plug something in. So we have several word problems in our notes, and they are a bit time consuming. So I'm only going to do like one word problem for each video, something like that. So we won't do all of this in one shot. But we have a problem where we're on a roller coaster ride, and this is the path the roller coaster follows. So they give you a function to represent the path of the roller coaster, so you can figure out its height based on how many seconds go by. We want to know how long the roller coaster is at or below ground level in the first 5 seconds of the ride. So what I would do first is on the graph, I would shade the portions of the graph that are below 0. So we have 2 of them. And then what I would do is I would label them with titles, and I just call them intervals. So from here and forever left is going to be beneath. That can be interval A. And from this point to this point where it's beneath, that can be interval B. So that's the next thing I would do. So you need to figure out what sections of the graph are they, or is the problem asking about. And then I'd make a few conclusions, and I would say to myself, I know the roller coaster is less than or equal to 0 feet tall at interval A and B. However, because T stands for time on the roller coaster in this problem, I'm going to reject interval A because I can't ride the roller coaster for like -5 seconds or -1 second. So I'm not going to include interval A when I go to figure out my answer. So if interval A is out, that means the only thing I'm interested in truly is interval B. Well, if I want to know how many seconds the roller coaster is below the ground, I need to know how many seconds until it hits the ground and then comes back up. So really, I need the x coordinates for interval B, or you could say I just need those x-intercepts. So here's the problem. I can tell from the graph that one of the intercepts is 2. I can see an x-intercept of -1. And if you want to make sure that those truly are x-intercepts, you could always just plug them in for t and make sure that you get 0. And you do. So they will be 2 x-intercepts, but I don't know this third one. It looks like it's between 4 and 5, but that could be any decimal, so I don't know the third x-intercept. So I want to show you 2 methods on how you can figure out that last x-intercept because we need that to answer the question. So I would make note that 2 and -1 are both zeros in this graph. They're both x-intercepts. When you're given an x-intercept, you may use it to do synthetic division. So I would set up my polynomial for synthetic division. So the coefficients for -21, 9, and 34. And it's up to you. You may divide by 2 or -1. They're both zeros. They're both going to work. I chose to do 2 first. And we run that through the synthetic division process. So we drop the 4, we multiply, and we add. Multiply and add. Multiply and add. So if you notice, you'll get a remainder of 0. If you're dividing by an x-intercept, that means you're going to get a remainder of 0. So if you don't, you know you made a calculation mistake or something along the lines of this synthetic process, because it should work out. And then what I want to do is take this information and present it in factored form, just so I can kind of see everything laid out. So if 2 is a 0, that means t minus 2 is a factor. That's from our factor theorem. When you go to write your answer for synthetic division, all your powers go down by 1. So it started as a cubic, and now it's going to start as a quadratic. So we have part of our polynomial factored. If you were to FOIL this back together, you would get back to the very beginning. Then we have to keep factoring. We have to factor this quadratic. We could use the x method and keep factoring it that way. However, if they gave you another 0, synthetic division is going to be a lot faster. So you're going to take your 4, your -13, and your -17, and you're going to factor out the next 0, which was -1. Drop your 4 and begin. So we multiply and add, multiply and add, and once again, you should get a remainder of 0 because you're using an x-intercept. So what I'm going to do is change this part to, I still have the t minus 2, but my 4t squared minus 13t minus 17 factors into t plus 1, and that comes from right here. And then my leftover, well, if I started with quadratic, now I start with just t to the first. And then minus 17. So what I did is I took this big polynomial and I factored it into 3 separate factors. Each factor will yield an x-intercept. So you would set each of these parentheses equal to 0 and solve for t. So you'll get 2 and -1, of course. We knew that those were zeros, but you can see them in the factorization. But what we didn't know was that the third 0 was at 17/4 or 4 1/4. So you can use x-intercepts with synthetic division to help factor a polynomial. And once your polynomial is completely factored, you can find all x-intercepts. So what I'm going to do in my next video is take you through the same problem, but I'm going to show you a different method of figuring out where those other x-intercepts are, and we'll just call it method B, but that's what we'll cover in the next video.